Hey, I'm Joe with Inch Calculator, and today we're going to talk about how to convert a binary number to a decimal, and we're going to go through a few examples to hopefully show you just how easy it is. Stay tuned to the end, and I'll show you a really cool tool to make solving conversions like this really fast. Also, if you're trying to convert decimal to binary, be sure to check out our other video on how to do that. Alright, let's get started. Before we begin, we should probably cover what a binary number is. A binary number is made up of just two digits, a 1 and a 0, continuing in any length. Since there are only two digits, we call this a base 2 number system. A decimal number, on the other hand, is made up of 10 digits, 0 through 9. Since there are 10 digits, decimal is a base 10 number system. These are both different kinds of numbers, but they mean the same thing, just using different digits. To convert a binary number to a decimal, you can use what's known as the positional notation method. To use this method, multiply each digit in the binary number from the rightmost number to the left by 2 to the power of n, where n is the distance from the right. So reading the binary number from right to left, the furthest digit to the right is equal to that digit times 2 to the 0 power. The digit that is one position from the right is equal to the digit times 2 to the 1 power, and so on. The binary to decimal formula looks something like this, and if you're anything like me, then this probably will make more sense when we see it in action with an example. So let's try an example and convert the binary number 1101 to decimal. Starting from right to left, we'll multiply each binary digit by 2 to the power of its distance from the right. I find it's a little easier to add some space between each number. Alright, the first digit to the right is 1, and it's 0 digits away from the right, so we'll multiply that 1 by 2 to the power of 0. 2 to the power of 0 is always 1, so this reduces to 1 times 1. So that's 1. The second digit from the right is a 0, and it's 1 digit away from the right, so we'll multiply 0 times 2 to the power of 1. Since 0 times any number is always 0, the result for the second digit is 0. The third digit from the right is a 1, and since it's 2 digits to the right, we'll multiply 1 times 2 to the power of 2. 2 to the power of 2 is 4, so this reduces to 1 times 4, which is equal to 4. The fourth digit from the right is a 1, and it's 3 digits to the right, so we multiply it by 1 times 2 to the power of 3. 2 to the power of 3 is 8, so this is reduced to 1 times 8, which is equal to 8. Okay, so the next step is to take all these converted numbers for each position and add them together. So in this example, we need to add 8 plus 4 plus 0 plus 1. The result is 13. So the binary number 1101 is equal to 13 in decimal. I usually find it helpful to refer to a power of 2 table for each of the powers of 2 because I find it just makes things a little quicker. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, and so on. I'll add a link to that in the video description if that helps you out. Let's try another example and convert 10101 from binary to decimal. We start by adding a little space again. Following the steps we showed above, the first digit from the right is a 1, and it's 0 digits away from the right. So we'll now multiply 1 by 2 to the 0, which is 1. So this reduces to 1 times 1, which is 1. The second digit from the right is a 0, and it's 1 digit away from the right, so we'll multiply 0 times 2 to the power of 1, which is 0. The third digit from the right is a 1, and it's 2 digits from the right, so we'll multiply 1 times 2 to the power of 2, which is 4, which reduces to 1 times 4, which is 4. The fourth digit from the right is a 0, and it's 3 digits from the right, so we'll multiply 0 by 2 to the power of 3, which is 0. The fifth digit from the right is a 1, and it's 4 digits away from the right, so we'll multiply 1 times 2 to the power of 4, which is 16. Then we just add these together. 16 plus 0 plus 4 plus 0 plus 1 is 21. So the binary number 10101 is equivalent to 21 in decimal. And hopefully you're noticing a pattern. So let's go through this one more example to make it really clear. Let's convert 110110 from binary to decimal. The first digit from the right is a 0, and it's 0 digits from the right, so 0 times 2 is 0. The second digit from the right is a 1, and it's 1 digit away from the right, so 1 times 2 to the power of 1 is 2. The third digit from the right is a 1, and it's 2 digits away, so 1 times 2 to the power of 2 is 4. The fourth digit from the right is a 0, and it's 3 digits away from the right, so 0 times 2 to the power of 3 is 0. The fifth digit from the right is a 1. It's 4 digits away from the right, so we get 1 times 2 to the power of 4, which is 16. The 6th digit from the right is a 1, and it's 5 digits from the right, so it's 1 times 2 to the power of 5 is 32. Now we just need to add these all up to get our decimal. 32 plus 16 plus 0 plus 4 plus 2 plus 0 equals 54. So that's our answer. All right, hang tight because I have a really cool tool to show you to make all this even easier, but I really wanted to invite you to ask any questions that you have in the comments below. And also, if you think we've earned it, we'd really appreciate if you liked this video and subscribed. Okay, shameless plug over. You can now do this conversion using our binary to decimal calculator. As the numbers start to get a little larger, doing this by hand is a little time consuming and tedious. So we created a calculator to speed up this process. It also shows every step so you can see exactly how we got the answer and do it yourself. I'll add a link to that to the description below. And that's how you convert binary numbers to decimal. We hope this helped you out. We'll see you in the next video.